Good morning or good afternoon. Happy Monday, everyone. It's Miss Fenton from Stevenson High School, and welcome back to AP Psychology Review. Just a little screenshot I wanted to show you. So hello to all the AP Psych teachers who might be watching. If you're looking for those FRQs that I mentioned yesterday that the College Board made available to students that you don't even have to assign, if you want to see them as a teacher, you go to Question Bank and click on Progress, and then you'll see an additional tab that says Optional Student Practice. So hopefully your students have found these. They're, great bank of practice FRQ questions with rubrics. So today we're going to start off by going over the AP Practice FRQ from yesterday, and we're going to be talking about cognitive psychology. So we're going to start our attention with memory. And there's far more to cognitive psychology, but for today and tomorrow, we're going to do a deep dive into memory. And this was your FRQ that I gave you yesterday. It's a concept application and has 8 points. So we're going to kind of go through this point by point and hopefully check your answers and that you scored a lot of points. Zachary has been promoted to shift manager for the lifeguards at the public pool. He will be responsible for creating the schedule, training new lifeguards, supervising employees, and creating a positive, fun, and safe environment. How might Zachary use the following concepts from psychology to effectively do his job? So this is concept application. So for all of these terms, you have to apply them to the scenario. You don't have to apply each term to every piece of the scenario. So for one term, you might focus on supervising employees, another one you might be focusing on training. So it's just kind of, sometimes a prompt gives you more information so you have more to work with to create your applications. Our first term is negative reinforcement. And if you remember from yesterday, this is following a voluntary action with a subtraction, negative means subtract or minus, an aversive, which is something bad, stimulus, that's going to make that behavior more likely to occur in the future. So in your application, you have to have all those pieces. You have to have a voluntary behavior, you have to follow it by subtracting an aversive stimulus, and then you have to indicate that that behavior increases or is more likely to occur again. So when you write your FRQ for the exam, you don't have to have a definition, but your application must have all of those pieces. If you do not, for example, have that behavior increasing again in the future, then essentially we don't know if the person even learned, right? So the lifeguards complain about feeling hot sitting in their chairs, and Zachary gives them a hat. So when they put on the hat, okay, that's your voluntary behavior, they feel less hot. That's subtracting less hot, the aversive stimuli of being hot or overheated. And in the future, the guards are more likely to put on a hat when they feel hot. This makes Zachary's lifeguards more comfortable and better able to do their job. So I'm making it really clear that we're talking about Zachary and how he's using this to create a better work environment. The next one is positive punishment, and this is another operant conditioning consequence. So you're going to have a voluntary behavior or an action followed by the addition of an aversive stimulus. And this is designed to make the behavior less likely to occur in the future. So I gave you 2 examples here, and all of these examples, they're not exhaustive. There's so many ways you could write this. If you have a question about whether your particular answer would score, you should ask your teacher. But you could also check to make sure you have all 3 pieces. So when a lifeguard is caught texting, there's your voluntary behavior. While on duty, Zachary has them clean the locker rooms and bathrooms, which they hate. So there's the consequence, the addition of something aversive. You notice I added which they hate, because I want to make it clear that cleaning the locker rooms is something aversive. Maybe some people like cleaning the locker room. So you want to make sure that you're clear. In the future, this is how you really know it's punishment. The lifeguard does not use their phone on duty. So that behavior is decreasing. Or a shorter one, when a lifeguard wears headphones on duty, Zachary gives him a boring lecture. So there's your addition of something aversive, something boring. The lifeguard does not wear headphones on duty in the future. Okay, escape conditioning. So this is a broader term. It's a type of learning. And escape conditioning includes negative reinforcement, but you want to also make sure that you're talking about this broader term. It's a type of learning where an organism learns, right, that a particular voluntary behavior causes an aversive stimulus to stop or be removed, and then they repeat it. So Zachary and the guards do not like the chlorine smell in their hair after work. So that's like your situation, your stimulus. They've learned to wash their hair with a special shampoo after every shift to remove the chlorine smell. And they continue to do this in the future. So you want to really make sure that you are indicating that this behavior increases. That's that learning piece. And remember, you have escape conditioning. So your easy synonym for conditioning is learning. Okay, so we had these different schedules of reinforcement, and these are a little bit more complicated to describe than you might think on the surface. But a variable interval schedule is one in which a reinforcement is given for the first correct voluntary response after an unpredictable, there's your variable piece, amount of time, that's your interval, of say minutes, days, hours has passed. So what Zachary is going to do, because it has to apply to Zachary, he's going to check on his employees to make sure that they're on task. His employees stay on task. There's your voluntary behavior, your voluntary response, because they want positive feedback. That's that addition of a reinforcement. And they never know when. That's your interval. Is it going to be, is Zachary going to check on him every 15 minutes and then maybe 3 minutes later, then maybe another hour, maybe 2 hours, maybe 10 minutes later, that Zachary will come by and provide feedback. And that interval schedule is going to keep those workers maybe on task consistently because they never know when that's going to happen. Okay, discriminative stimuli. These are stimuli or factors, that's what a stimuli is, in the environment that indicate to the organism, the person or the animal, that a voluntary behavior will lead to a reinforcement or not. So Zachary's employees know that when he is singing as he works at his desk, so there's the specific factor, that's the stimulus, that if they ask him for a last minute schedule change, that's their voluntary behavior, that Zachary's likely to say yes, that's their consequence, their reinforcement. So that means in the future, they're going to do that again. So normally we've been talking about operant conditioning consequences. We're talking about that consequences step, like whether after the person does the behavior, do they receive something that increases their behavior, a reinforcement, or are they having a consequence that decreases their future behavior, a punishment? With discriminative stimuli, you're kind of focusing on that stimulus. So if you remember, like the mouse might have learned that if the green light came on, that's the discriminative stimuli, the green light, that pressing the lever will result in food. And if the red light comes on, that pressing the lever won't result in food. So the mouse won't press the lever except when it sees that discriminative stimuli, when it sees that green light. Shaping is the process of creating a new voluntary response, so it's learning, by providing reinforcements for successively closer approximations of the desired new action. So in your application here, you want to make sure you have those keywords. You want to have that new voluntary response, which is rescue methods, and you want to reinforce them with something. So in this case, praise for successively closer approximations of that desired response, which is the correct rescue method. Now, Broca's area is a little bit of a simpler term. This is just an area in the brain. In most people, it is in the left frontal lobe, and it's responsible for speech production. So Zachary assigns 2 lifeguards each shift to watch the weather. If they see lightning or hear thunder, they call out a warning. And just to be sure that, you know, whoever's reading this is positive, they know what we're talking about. Broca's area in their brain allows them to produce the speech and the warning that they call out, right? So call out is speech, so that probably would be okay. Vestibular sense is responsible for maintaining balance and equilibrium by determining the orientation of the body by monitoring the position of the head. So remember, with this sense, transduction occurs in the semicircular canals. So you probably don't have to add that extra piece about where transduction happens, but that is that idea of going deeper potentially. And when you're studying the senses, you want to pay attention to where specifically does transduction occur. So with vision, it's in the rods and cones. You really want to know that. With the audition sense, with hearing, it's in the basilar membrane of the cochlea. That's where sound waves get transduced or turned into a neural message. So focus on transduction. That's just a side tip. Now, in your example, you want to make sure that you use those terms, so balance and equilibrium, and apply it to the scenario. So that was an 8-term FRQ. Congratulations. I'm impressed if you attempted all 8. Hopefully you did well. Just check over your work. Did you space out your answer? Hopefully you answered them in order. You included a definition, or you made sure that all aspects of those definitions were in your application. And you double check to make sure that you had some synonyms, and hopefully you made it in under time. Okay, let's get started with memory. If you take memory, it's a part of cognitive psychology. It's a part of the cognitive unit. And you may have had this as a standalone unit or a chapter test potentially in your class. If you took everything you learned in memory, you could probably fit most of those concepts under one of these three categories. So memory is cognition, so it's thought, and it involves the encoding, storing, and retrieving of information, and how that leads to persistence of learning over time. So sometimes we use a metaphor like with a computer. So encoding would be like typing your document. Storing would be hitting save, right, and saving it somewhere on your hard drive. And then retrieving would be taking that information out of memory. So maybe a week later, you can go back in and pull out that document. So a couple of terms here I want to separate. We have this idea of effortful versus automatic processing. And with effortful, it might be called controlled processing in your textbook. So effortful and controlled are the same. These are mental activities, so whether it's encoding or manipulating material that require focused attention, right? It'd be difficult if you were doing something that required effortful processing to be doing something else. So encoding and rehearsal are kind of like working out. So if you stop, you're going to lose some. If you stop working out, you're going to lose some, but not all of your strength, and you're going to have some like long-term acquired benefits that remain. So examples of effortful processing are complex behaviors. So this would be texting, listening in class, solving a difficult problem, and they require a lot of conscious attention. Doing more than one task that involves effortful processing requires something called task shifting. So you're really not doing both at the same time. You're moving back and forth, from one to the other. And every time you shift in task shifting, you lose a little bit, right? So you're less effective at essentially both tasks. With automatic processing, these are your mental activities that require very little of your attention, right? You can do them like on automatic, like autopilot. And this would include things like procedural memories, like, how to ride a bike, and unconscious processing of information, like of space and time and frequency. So for example, if I were to ask you, where were you yesterday? What were you doing at 5 p.m.? You can probably answer that, even though you never spent time yesterday kind of consciously studying this, because who knows, somebody might ask you this. If you lose your cell phone, you can easily retrace your steps mentally, like where you were in the school day, and kind of trace yourself back and find your phone, even though you didn't consciously, effortfully encode the path that you took through the day. So you can't even turn that off, even if you want to. So an interesting example of effortful versus automatic processing is this idea of the Stroop effect. So you've maybe seen this before. You can read the words. So if you just want to read the words, you can do that much faster than if you were to say, go through each word, and instead of reading the word yellow, say the color of the ink. So you would read it as red and then blue, even though it says yellow, orange. If you do this and you time yourself both ways, you're going to be much faster at reading. And that's because reading is an automatic process. And it's actually hard to shut off that like fast system. Another kind of terms that you might see in other chapters, in some books it might be in memory, but it could also be in sensation and perception. It could possibly be somewhere in your text with states of consciousness or somewhere with the brain. But we have this difference between selective attention and divided attention. And again, these both refer to a certain amount of automatic processing, but there's more automatic processing going on in divided attention. So attention is kind of like a filter. It screens out most stimuli while it allows some to go by, right? So with selective attention, it's this usually conscious focusing of awareness on stimuli or on a task, and then you're blocking out other things. It's kind of the idea of paying attention to something. So you're going to maybe pay attention, focus on what your teacher is saying, and ignore the conversation that is being held between two people sitting next to you. So there's a lot of different examples of selective attention that you've talked about potentially in this course. So one of them is the cocktail party effect. So in a noisy environment, you can selectively attend. You can focus your awareness on one person and have a conversation and kind of tune out all the noise of, say, the dance. But yet there's a part of your brain that's on automatic processing that would pick up really important information, like if somebody said your name. Divided attention, another example also of selective attention would be inattentional blindness, right? So if you're focusing so hard on one particular task, you might actually miss something in your field of vision. With divided attention, you are doing things concurrently. So you're doing two things kind of automatically. So you are, when you're maybe driving, you're doing some things automatically. Metacognition is an active cognitive process that involves control and understanding your own thinking. And sometimes a really short definition of metacognition is thinking, that's what cognition means, about your own thinking. That's the meta piece. And metacognition is a really important component to successful learning. And education it's certainly more than memorizing facts. It's also about becoming a reflective person and learning to evaluate your own thought processes and make healthy adaptive responses to change or stressors. And metacognition includes also monitoring of your memory. And when you do test reflections in your classroom, sometimes when you get your test back, you might look at your answer and maybe you got something wrong. So the answer was, say, choice C, but you picked B. When you are saying to yourself, well, I understand why you might think it's right, C is right, but I picked B because, and you're explaining your mental process, you can actually remember why you answered the way you did from the day before. That's being metacognitive, and that's really powerful for your learning. So this is, really great as a teacher when you see our students reflecting, really thinking about their answer choices that they made. And sometimes it's a really great way if students share that with their teachers or their peers to clarify a misconception that they had. Sometimes when the student reflects about how they answered a question, they might tell me, they thought it was B because blank. And sometimes, the student's right. And actually maybe B was also true. Maybe, I could have wrote the question a little more clearly. Another type of metacognition is this idea of the tip of the tongue phenomenon. So you can't quite think of something, you know the word, but you just can't pull it out of memory. And when you're going through that process of in your head trying to make the connection and pull that piece out of your memory, that is metacognitive. So I can maybe give you a quick example. If you can think of the name of the instruments, they're like little round pieces of wood that are tied together connected by like a cord or a string, and they're often used to keep rhythm in Spanish dancing. So is that on the tip of your tongue? Now, if you've never heard the term before, you're not experiencing tip of the tongue, but if you can't say it, but once you hear it, they're called castanets. An informal name for them would be like clickers or clickers, click clack, like finger cymbals maybe. But the name I was looking for was castanets. And it's also important to remember that if you're stuck in the tip of the tongue phenomenon state, that sometimes it's better to just look up the word. There's some research that suggests that maybe spending that time spinning in the tip of the tongue phenomena, what you're really doing is you're encoding the incorrect pathway to that memory over and over and over. So sometimes it's better to just, stop and look it up. Okay, so just going to give you some tips to study on your own. I would suggest strongly that you practice maybe making connections between concepts within a unit and across units. So potentially you could write an FRQ and explain how divided attention connects to automatic processing. How would you write that as an application? How could you connect cocktail party effect to both effortful and automatic processing? And how might you connect metacognition to effortful processing? Okay, so we're going to get started with the memory processes. So today we're going to do encoding and storage, and tomorrow we're going to move on to retrieval. So you have these three processes: encoding, storing, and retrieval. And we're going to focus mostly on this effortful processing of things that go into long-term memory, right? There's also ways for things to go into long-term memory through automatic processing, like procedural memory. But today we're going to focus on the other. With encoding, this is that part of the memory process that is analogous to typing a document on your computer. So there's three main ways. You can do it visually, acoustically, or semantically. And each of these are associated with a different level of processing. So with visual encoding, it's sometimes called structural, but visual encoding is a shallow processing that involves putting info into your memory system, basically by how it looks, by its appearance, maybe emphasizing the physical structure of what you're looking at. Acoustic, also called phonemic encoding, is intermediate processing. It's a little bit deeper, it creates a little bit more of a durable memory. And this is creating a mental representation of information as a sequence of sounds, right? So you're putting something into your memory system based on how it sounds. And then finally, we have semantic encoding, which is the deepest level of processing. It's going to create the strongest memories, the most durable memories, and the ones that are easiest to retrieve. And this is putting information into your memory system by emphasizing meaning. This would be techniques like rephrasing things, meaningfully connecting things to existing knowledge. So if you want to think about an example of how this might look when you're studying, is if you've ever had that experience on a test where you know the answer, like you're looking at it and you can imagine where it is on the page in your textbook, like, it's on the left side, it was next to a cartoon, it was in green font. You can't answer the question, but you can describe where that answer to that question is. If you've done that, that means you've only visually encoded it. So your study method was such a shallow processing level that you can't actually retrieve it. You have the memory, you put it in your long-term memory, you just can't quite get it out. So here's just a couple exam tips. If you're thinking about acoustic encoding, imagine an acoustic guitar and the sounds of an acoustic guitar for acoustic encoding of sound. If you are thinking about it in terms of phonemic encoding, which is the same term, just you can notice that even the word phone is inside of that word. So again, deeper processing produces longer lasting memories. So visual encoding, shallow processing. Acoustic encoding, intermediate processing, a little bit better. So maybe when you study, also say things aloud. Practice by talking out your answer. And the best way, of course, semantic encoding, deep processing. When you rehearse, okay, which is the conscious repetition of information, either to maintain it in your memory system or to encode it for storage, right? There's two broad types. There's maintenance, which is just repeating and repeating without meaning. And then there's elaborative, which involves often semantic encoding, deep processing. You're putting as many associations, vivid associations. You're making applications, you're relating it to prior knowledge. If you are using elaborative rehearsal in terms of the self-reference effect, you are taking material to be learned and trying to create examples or ways it applies to you personally. And that's a really powerful way to improve memory. And then creating visual imagery. This is not the same as visual encoding. That's just looking at things. Visual imagery is deep processing because you're creating new images. It's semantic encoding. When encoding doesn't work, it's often due to one of these problems, right? So you didn't pay enough attention, you used too shallow of a processing, or you were trying to do too many things at once. With storage, you have this three-stage model, right, that describes three sequential stages of moving things deeper and deeper into memory. So you start with the sensory memory store, and then you move to the short-term memory, and finally long-term. Sensory memory or sensory store, right, this is where in the storage piece, is the first stage in this information processing model, and it's a very, very short. So if it's iconic, you're talking less than a second. If it's echoic, maybe 3 or 4 seconds. Brief recording of information via the senses. Most of this you don't pay attention to, and so it doesn't go deeper into the system. So an iconic memory is a very brief visual image. So far today, maybe you went on a walk. You've seen so many images, so many things. Most of those you didn't pay attention to, and so they never made it to short-term, much less long-term memory. You've completely forgotten them. And a good example of an iconic memory is this idea that we blink, right? Not a blink that you blink on purpose, but like the involuntary blinks that happen 14,000 times approximately per day. when your eyes close during these blinks, you don't actually see like complete nothingness, like if you were to actually just close your eyes, right? So your brain holds on to that brief fraction of a second image of what you were just looking at, and that gives you continuity of vision. With echoic sensory memory, these last a little bit longer. So you may have had the experience where you're like engrossed in reading a book or you're doing something and your mom comes in and says, you know, what time are you leaving? And as soon as you say, what did you say? You realize you actually did hear the question and you can answer it because that memory lasts a little bit longer. So here's a just quick tip here for memorizing iconic and echoic. They both have large letter O's and so does sensory memory. You can also think of iconic as an icon or a picture on your computer or an eye, right, for vision. And echoic, imagine that you're hearing the sound of an echo, right? And that's like what your mom asked you when you were engrossed, you're hearing the echo. And what sensory memory does also is it gives that stability, which is that consistency. Okay, so this is short-term memory test, and we're not going to take the entire thing because it might take a little bit too long, but we're going to go through a little bit and see how you do. Okay, can you remember those three numbers? If you said 925, you were correct. So now I'm going to give you four numbers. Did you have 8642? We're going to do five numbers. How many did you get? I can show you the answer. 6. Try 7. How'd you do? If you had these four, you were correct. Let's up it to 8. How'd you do? And we're also not having too much distraction between these tasks, but it should be starting to get a little bit harder. Let's try 9 numbers. And how'd you do? You can keep adding these. Okay, and that was just a little demonstration of your short-term memory. So after something is in sensory memory, if you pay attention, then you can put it into this short-term memory, which has a capacity, a durability of about 3 to 12 seconds. And this researcher, George Miller, said it fits about 7. So you're probably able to do about 7 of those numbers, right, where you were accurate. So George Miller actually said 7 plus or minus 2, which is just a really fancy way of saying between 5 and 9. George Miller also talked about chunking. So grouping information to be memorized into groups, like taking information to be memorized and putting it into groups. And that creates these like chunks, right? And that's what it does is it can increase your short-term memory capacity. So what we have here are a list of 25 words, which is more than 7 plus or minus 2. So can you fit it into 3 chunks, 3 phrases? And a hint here is that these are songs. Give you a few moments to try to solve this puzzle. These are songs that are potentially popular right now. You may not know all of them, but I did ask some 17 to 20-year-olds to give me some examples of popular songs. So hopefully you can pull these 3 out. If you need another hint, one of the songs is by The Weeknd, and another one is a new song, I believe, by Drake. So while you can't memorize these 25 words or so, you can potentially memorize these 3 short lines from 3 songs. Now, George Miller's theory of short-term memory, the 7 plus or minus 2 traditional model of short-term memory, has been expanded, and we now talk about it more as a working memory model, and that it's a little bit more active. So you have this central executive piece of your short-term memory that focuses your attention and helps move things in and out of short-term and long-term memory through what's called an episodic buffer. You also have auditory rehearsal, which is sometimes called the phonological loop. And you have a visual spatial information, right, which is your visual picture, your temporary storage of images. So this is just a way that you're working with your short-term memory before pushing it through attention into long-term. Now, with long-term memory, you have unlimited capacity and generally permanent storage. Just because you can't pull something out of long-term memory, it doesn't mean it's not there, right? So you may have forgotten something, but it's in your memory, you just can't reach it. And we're going to talk a little bit about retrieval problems tomorrow. So long-term memory, you have these two broad categories. You have implicit, sometimes called non-declarative, and there's 3 types. And you have explicit or declarative, 2 types. With implicit, you have the most well-known type of implicit memory, which is automatic processing, is procedural. And this is that category of long-term memories for skills or habits, like how to ride a bike, how to eat with chopsticks, how to play a violin, how to snowboard. And these importantly are encoded, they're related to the cerebellum in the brain. Priming is something that we talked about, Dr. Swope talked about already in sensation and perception, but it's actually a type of implicit long-term memory. So this prior exposure to a stimulus that facilitates later processing is a tiny implicit unconscious memory. And then conditioned responses are also implicit memories. So this is a long-term unconscious memory for an association between a conditioned stimulus and an unconditioned stimulus that creates that reflex. So when that dog salivates, when Pavlov's dog salivates to the bell, it's because he has an unconscious memory that connected that bell with the meat. On the other side, you have explicit or declarative memories, and you have semantic memories for facts, and you have episodic memories for events that are personal experiences, right, and tied to specific times and places in your life. So with semantic memory, you might remember that Paris is the capital of France, and with episodic, you might remember your personal trip to Paris, right? So episodic would be you remember your first high school dance, or remember visiting your state capital, or the day you took an AP exam. This is just a nice summary image that you can use to study from. So I'm just going to leave that up for a second. And again, always feel free to pause, go back, really pay attention to the tips especially. So here's some tips for semantic. This term you're going to see more than once, right? And I really want to point out that there are 2 times we've used semantic today. Semantic always refers to meaning, but there is a difference between semantic encoding, putting information into memory using meaning, like the self-reference effect or coming up with examples, and a semantic long-term memory, that's storage, right? So that's a memory for a fact that you have in your long-term explicit memory. You're also going to see that there's semantics in grammar. So the term semantics, when you're talking about language, is a component of grammar that involves the system of rules for using words to create meaning, right? So semantics is part of grammar. Broadly, when you look at long-term memory, you can think of it as 2 halves. So you have retrospective memory. And usually when you're thinking about memory, you're thinking about retrospective memory. So it's your working memory, it's past events, right? Your episodic and your semantic memories of facts. But prospective memory is remembering to do something in the future. And it might be like monitoring, right? So checking to make sure your cookies don't burn, remembering to check your email from the College Board every day leading up to the exam. There's a hint. Or it might be remembering to do things in the future, remembering to have your permission slip signed by a parent, remembering to take a medication. And prospective memory fails are common among all ages. So prospective memory is remembering to do something in the future. Also, just another note about schema. So schema are these like broad categories or mental frameworks. It's how we organize information and experiences to make faster, better responses and perceptions. And we remember schema consistent information better. And schema can also distort memories. Like we might assume that something was there because it should be there, right? So if you have a schema of what a college dorm room looks like and you visit one, and you might remember that there was a desk there because you would assume that there would be, right? Or maybe there were posters or something on the wall, or little strings of lights because you expect that to be there. But maybe there weren't little strings of light, your schema put those in there and then they weren't there. So your schema can impact your memory. Okay, so let's take a look at this example. participants were randomly assigned to two different groups. Both groups were given the same list of adjectives. Group A was asked to rate the words according to how easy they were to pronounce. Group B was asked to rate the words according to how well they describe themselves, like themselves personally. Later, they were then given maybe a distraction task, and then they were asked to write down as many words that they could remember. And Group B remembered more words. So first of all, what type of encoding might have helped Group B be more successful? And what level of processing was that? And next, what kind of rehearsal did Group B use? So this is a way to look at memory in the context of a research question. Check your answers. So this would have been semantic encoding. So the self-reference effect, which is what they were using, is elaborative rehearsal, and it is deep processing. Okay, looking at this same study, what research control was used in this study to allow for a potential cause and effect conclusion? And could you come up with an operational definition, something measurable, of the dependent variable in this study? So this is another way to kind of practice and get ready for potential research methods questions. So if you need to pause the video, you can. I'm going to show you the answer, see how you did. So one research control that allows for, the one that allows for cause and effect conclusion is random assignment. Now there are other controls in this study, like in theory, you would have given them the same list, you would have kept the list of adjectives the same, but what allows for cause and effect conclusions in an experiment is random assignment, placing individuals or participants into the control or the experimental group by chance. And an operational definition of the dependent variable in this case, you would have to say the number, something measurable, of correctly remembered words. And okay, debrief and summary. So just a couple broad ideas of some of the terms we covered today. We talked about encoding, we talked about encoding, storage, and retrieval broadly. We talked about moving from sensory to short-term to long-term, and the more modern interpretation of short-term memory as the working memory model. And this is that image that I showed you at the beginning. So here you have all of the different concepts that fall under encoding that we talked about today, and the ones that we talked about for storage. And there's certainly more, right? So we, in this review session, can't cover as much as you might have in a class. So you can feel free to add to this. And then maybe you want to take some time and fill in the retrieving box before we go over this tomorrow. That way, maybe you can see what you already know. Okay, so for exam practice, I'm going to give you the following FRQ practice for tomorrow. We're going to go over the answers at the start of the review session tomorrow, and this is a research methods FRQ. And I made it 6 tasks because you're going to have a 6-task research FRQ, and you're going to have 15 minutes on the AP exam to do something like this question. When it's concept application, you'll have 25 minutes and 8 terms or concepts or tasks. So here's your question. And this is an actual study. So in a memory study by Martinez and Kessner in 1991, rats were randomly assigned to one of 3 groups, right? So you're going to take a look at what happened in the study. You're going to examine the results, and then you're going to answer these 6 bullet points. Now, this is a perfect example of where it might not be necessary to define, but you want to, again, if you're talking about an operational definition of a dependent variable, I don't think you would need to define operational definition and dependent variable. You're going to give that example, but include all of the concepts that are part of that concept. So again, you're not going to describe a descriptive statistic, but you're going to give me an example of a relevant descriptive statistic that researchers could include about the dependent variable in the study. So read very carefully and take some time, set a timer, 15 minutes, and we will go over these answers tomorrow. Thanks for watching, and I hope to see you again. Take care.